Hey, how's it going? My name is Jacob Levy, and I am a current Cornell University computer science student, as well as a current software engineering intern at Google. In this video, I want to go over a topic that I learned in my introductory classes at Cornell that I think is hard for a lot of people and was hard for me, but that I think I learned in a really interesting way that made it really easy for me to understand and grasp this thing. And that thing is recursion. If you've ever taken an introductory CS class before, you know that recursion can often be a difficult thing to learn. I know it was for me for sure. But this technique that I'm going to go through called call frames, and there's an online tool called the Python tutor you can use to visualize these call frames, is really, really useful for understanding what's going on under the hood in a recursive function. And what a recursive function is, I'm going to get into in a bit. But first, I'm going to start by stating the problem. So the problem we're going to go through today is called factorial. Now, if you've ever taken a high school math class, or even maybe a middle school math class or junior high school math class, you've probably seen factorial in your math classes before. All factorial is denoted by this exclamation point symbol here. And it's you take a number, it's a function applied to a number, and all it is just that number times the number before it, times the number before that, times the number before that, all the way until you hit 1. So that's just the definition of a factorial of a number. And we're going to just think about positive whole numbers here. And in our case, factorial of 5 is 120, I believe. And factorial can be used for a lot of things. It can be used a lot of times in probability theory, or if you're thinking about, the number of combinations of things, it's often very useful. Not going to really get into it in this video as to why it's used, but more going to get into it as an example of how to solve something recursively. So for the code for this video, I'm going to write in Python. The Python tutor, which is this online tool I'm going to use, also supports other languages. Even though it's called the Python tutor, you can use older versions of Python, Java, C, C++, Ruby. But I like to use it in Python. That's the language I know best. What we're going to try to do is write a function that can do this for any number. So we want to define a function called factorial that takes in any number n and gives us back factorial of that number. So to think about how to write a recursive function, you might have heard this if you've taken a CS class before, but to write a recursive function, you want to think about a base case and you want to think about a recursive case. It's often the structure of the problem. So for us, a base case is when you no longer have to really think about what the next computation is. And what that means is for what numbers of factorial do you not have to compute anything actually. If you think about it for a second, if you have the number 1, you actually never have to compute factorial of it, right? Because factorial of 1 is just 1 always, right? And you could hard code this for the numbers. You could do that if you'd like. But we're just going to say, okay, factorial of 1 is a base case, right? You no longer have to compute the factorial of 1. You just know it is 1. So if n is equal to 1, this is the base case. We're just going to return 1 to the user. Now, that might not seem like a really useful thing at the moment, but you'll see in a second why this is really essential to writing a good recursive algorithm that works. So in any other case where n is not equal to 1, which is going to be else, which is all other cases, what we're going to want to do is return n times factorial of n minus 1. Now, this might look a little bit weird. It might not even make sense how or why you can call the same function within a function. That seems very circular, seems like it might break the computer. But I'm going to go through in a sec and show you how this works under the hood, and how this is not magic, even though it might seem like magic, and what the computer is actually doing to make this elegant code work. But first, let's go back to the visual mathematical definition of factorial and see why this makes sense. So the factorial of 5 is equal to 5 times 4 times 3 times 2 times 1, right? So it's 5 times this quantity here. Now this quantity here is equal to 4 times 3 times 2 times 1, which is actually the factorial of 4. So you can see that definition holds, and it's going to hold all the way down, right? So hopefully that makes sense as to why this might be intrinsically true for some reason, but how this code works still might not make sense. So what we're going to do is use this awesome tool called the Python tutor, which I learned about in my introductory class at Cornell University, taught by Walker White. Great class, Intro to Python. If you're at Cornell, I would highly recommend taking it. What we're going to do is walk through an example. So we're going to print out, say, factorial of 4. Let's call it. Now, what the Python tutor allows us to do is visualize what's going on under the hood with our code. What that means is we're going to visualize our call frames. So we're going to see right now what that looks like. Okay, so there's 18 steps the computer is doing to solve this problem. Okay, so I'm going to start with the definition here. And this is just a definition, right? This is not any code that's being called. It's just a definition of something called factorial. So the first thing that's going to get called actually is this line, print factorial of 4, right? This is the first thing we're telling the computer to do. We're saying, hey, computer, print this thing. We're saying first define this thing, then print this thing. Okay. So now that we're doing that, we're going to print the factorial of 4. We have this frame right here, right? And this frame represents a function call. So right now we've called factorial one time. And when we pass in 4 here, number n is equal to 4, right? Okay, so the first line that's going to execute in factorial is going to check this if n is equal to 1. By the way, this red line, if you can read, says the next line to execute in green is the line that just executed. So the line we're going to execute next is this line here, if n is equal to 1. In our case, n is not equal to 1, right? It's equal to 4. Okay, so it's going to pass that and go all the way down to the other case. It's going to return n times factorial of n minus 1. Now you see that we called factorial again right here, right? So what that's going to do every time we call factorial, or anytime we call any function, but in our case, the only function we've written is factorial, we're going to create another frame. And that frame is going to look exactly like this, but with a new input. So factorial of n minus 1 is factorial of 4 minus 1, which is factorial of 3. So we're going to create a new frame with factorial of 3. And now you're going to see we're going to go through a similar process here, right? We're going to see if n is equal to 1. It's not again. We're going to go to the other case, and we're going to now create a new frame with factorial of n minus 1 again. But now in this function call, n is equal to 3. So n minus 1 is equal to 2. So we're going to go through that again. N is not equal to 1 again. So we're going to go to the other case, and we're going to return n times the factorial of n minus 1, which now is going to be factorial of 1. So now we have one last frame. We have factorial of n with n equal to 1. So we're going to check this case. Now, instead of going down here, we're actually going to go and execute this line right here. And you see now what it looks like when we get a return value. So when we get a return value, what's going to happen is this frame is actually going to go away. When a function returns, the computer no longer holds that function frame in memory. It just returns what you wanted back to the thing that asked for the answer and just erases that frame. So the frame that asked for the answer of this frame is this one actually, right? Because when n was equal to 2, we asked for factorial of 1, right? So this finally gave us the answer to factorial of 1. It's going to give it back to right here and then delete itself. Okay, so it deleted itself and gave us n times factorial of n minus 1, which is 2 times the value that was given to us before, which was 2 times 1. Now it's going to return 2. Now this frame is going to delete itself, give back the value 2 here. And in this frame, we're going to compute n, which is 3 times this return value, 2, and then return that and so on. So now we get 6 here. Then now we're going to return this and delete this frame. Now we get 24 here. And then finally, we print that out to the screen because that is what we asked for. So hopefully that shows a little bit of how a computer does recursion under the hood. It might still feel a little bit weird or a little bit magical that you can call a function within itself. But hopefully you can understand that under the hood, a computer is just going down and breaking the number down until it hits the base case and then builds back up once it hits the base case. And there's a lot of other problems. I might do another video going through some string problems because string problems are also very good for recursion. But hopefully this video gives a good example of how recursion works under the hood and how you can use call frames and this tool called the Python tutor to visualize basic recursive functions.